Hey guys, welcome to our second and final video on energy work power. So previously we talked about energy, different types of energy. We also talked about the two main formulas for kinetic and gravitational potential energy. And we also mentioned about, you remember the skateboard? About the conservation, principle of conservation of energy, how energy can't be destroyed or created, but only transformed. Okay? So, if you remember at the start of the last video, we also explained that what is energy? It's the capacity to do work. So, what is work? Okay, so we're going to go into the detailed explanation, the actual definition for work right now. Okay, work done by a constant force is basically a product of the force and the distance moved. But the thing is, the force and the distance move must be in the same direction of the force. Okay, for example, if I push an object here with a force F, it moves all the way to point B. On object at A, it moves to point B and moves the distance D. As long as you can see, distance D is in the direction of the force. Okay, so we can say that the work done is force times distance. Okay, where work is measured in joules, the same unit, SI unit for energy, right? And F is in newtons, and D is in meters. Okay, all these are the SI units that we need to be careful here. Okay, so with work, now that we know what work done is, let's go straight into an example. Okay, so just to take note, okay, these are two special cases for work done. If you're holding a book, all right, with the pile of books with a force F upwards, okay, and are the books moving? So since the books are not moving, no distance move, the work done is actually force times D, F times D, and D is 0 because no distance move. So that will be 0 joules. So no work is done if you're standing there. Okay, what about if you're holding the book and moving? Okay, so as you can see, F is pointing upwards because you need to push the books up, right? To hold it up. But you're moving in a direction perpendicular to the force. So since no distance moved, the distance d equals 0 because distance d must be parallel to the force to be considered to have a distance, right? So W equals F times D, which is F times 0. Again, in this case, 0 joules. No work is done in both cases. Okay? All right, so now that we'll go straight to an example. Okay, let's say I've got a Bugatti Chiron. All right, Bugatti car that's not working. Okay, what's going to happen? Since it's stalled, you need to push it. If you push it with a force of 1,000 newtons, okay, and it starts to move a distance of 15 meters, okay, what is the work done? Yes, you are absolutely correct. Work done is simply just force times distance, which is 1,000 newtons times 15 meters. That's 15,000 joules of energy of work, all right? Okay, what about right now? You seem tired, and somebody else, your friendly neighborhood Spidey, is coming to the picture, and what does he do? He pushes it with the same amount of force, 1,000 newtons. What's the work done? Do the same, right? Force times distance, which is also 15,000 joules. Okay? But do you notice something different between the two of them? Okay, both the similar thing is that both of them are pushing with the same amount of force, but Spider-Man is pushing much faster, right? So what does it mean? Okay, so if you are pushing, you take 5 seconds to move, for example, to push a distance of 15 meters, your power is simply just the work done divided by time. Okay, work done 15,000 divided by 5,000 divided by 5 seconds gives you 3,000. Oh, this is a new SI unit. Well, it's watts. Okay, but for Spider-Man, instead of 5 seconds, it takes only 2 seconds to push. So his power is actually the same amount of work, but divided by a smaller amount of time, 2 seconds, that gives him 7,500 watts. So you can see in this example, Spider-Man is definitely more powerful than you, right? Okay, because with great power comes great responsibility. Okay, so you can see work done is the same between you and Spider-Man. Both are 15,000 joules, but because you take longer than Spider-Man, okay, Spider-Man's power is increased. It's higher than yours. Okay, 7,500 watts for Spider-Man, 3,000 watts for you. That's mainly because of the increased time you take to push the car. Same distance, the same force. Okay. All right. So just to recap this new concept, this final concept over here about power. What is power? Okay, power is defined as just the work done per unit time. Okay, we got a full definition here, but I just want to simplify it. Okay, don't need to talk about rate of energy conversion, all that. Okay, so basically, just power is defined as the work done per unit time, or over here, work done over time, or energy converted per unit time. Both are in joules, right? So the power SI unit is known as the watt. Okay, what does 1 watt mean? It simply means 1 joule per second. That's it. Okay, hope you enjoyed this video, this last installment for energy work power. Okay, I will see you in the next.